Hello everybody, welcome back to Human Resource Machine. Let's pick up where we left off. 25 Cumulative Countdown. What is the purpose of this assignment? I think it's something about calculating the volume beneath staircases. We have to put the interns somewhere. For each thing in the inbox, outbox, the sum of itself, plus all numbers down to 0. For example, if inbox is 3, outbox should be 3 plus 2 plus 1. So this is just like the counting problem that we had earlier, except instead of just outputting all the numbers, we also need to add all the numbers together. So let's get our number out of the inbox first. And I guess we need to store that to here. Let's say this is our current count, and then also copy it to a second slot, and this will be our sum. So initially, say we have 3, count will be 3, sum will be 3, and then now I'll just bump down the count, so now it becomes 2. Let me test that it's not 0 first. If it is 0, then we can immediately send everything to the outbox. Okay, now after bumping, if it is now 0, if the count is now 0, then we have everything in our sum. So that means we can copy from our sum and send that to the outbox. We don't need that instruction because we're going to fall down here and send that to the outbox, so that's good. If it is 0, then we do that. If the count is not 0 yet, then we can add, or yes, actually, we have the decreased count. So let's say we had 3, 3, count becomes 2, and we want to add 2 over to our sum, and then jump back here because we update the sum with our new value, and then bump the count, decrease to 0. Let's try that. Alright, very good. Okay, this is one of the rare instances where I get the solution, the challenges on the first try. Remember last time when I told you you didn't need to divide? Well, now you get to small divide. For each 2 things in the inbox, how many times does the second fully fit into the first? Don't worry about negative numbers, divide by 0 or remainders. Self-improvement tip, this might be a good time to practice copy and pasting from a previous assignment. Oh yeah, that's a really good idea, because instead of doing remainder, we are doing the quotient, which means we still keep subtracting until, I guess, until we get something similar to the remainder last time, except we also keep track of how many times we have subtracted. That'll be our quotient. Do I want to? Sure, let's do that. Which one is, okay, mod module. This was our solution to that. So let's copy. Small divide. Paste. Alright. So this is our quotient thing. So we get our number. This is our original. We want to subtract the thing. If it's negative, that means we're done. Okay, somehow we need to keep track of how many times we've subtracted. So number 9 is already initialized with 0, so we can use this. No, we can't. Because we're going to run into the same problems because we cannot reset it back to 0 after. So let us copy from this slot and then copy it to slot 4. Let's call that the quotient. So this is our number. This is our divisor. This is our quotient. Every time we subtract and the result is not negative, I want to bump up the quotient. And then, why do we add divisor? We don't need to add divisor here. But what we need to do is, let's copy from our n. Okay, that is not going to work. We're missing a lot because we optimized the heck out of this last time. Okay, let's review. Copy to n. We have our divisor set up, our quotient set up. Start with our n, subtract the divisor. If the result is negative, then we're done with everything. So output the quotient. This is good. If it's not negative, then we need to update our quotient and also our n. So bump up our quotient. Yes. And then copy. No. Okay. We've already subtracted our divisor, so this is a good time to update the quotient. Update the n. And then we'll update the quotient. But then we also want to restore the value of n in our hands. Jump back so that we can subtract the divisor and try that again. Now, if it is negative, we also need to have the value of quotient in our hands. So copy from quotient. We are updating n correctly, and we are also updating our quotient correctly. And before we outbox, we have the quotient. Okay, let's try that. Ooh, okay, we actually did pretty good on the speed challenge. We just need to reduce size by 1. That was not totally expected because we needed to shuffle the numbers a lot. Like, we had to get the n, and then we have to change it to a quotient, and then we have to get the n again, and then like here we have the n, and we have to get the quotient again. We have to shuffle between these two numbers a lot, and so I didn't expect it to be super efficient, but that's a good thing. It's good to see that it wasn't that bad. Oh, here's something easy. We have copy from n, and then we jump over here where we just finished copying from n, so why not just put that down here so we don't need this. Awesome. Okay, we have number 28, 3 sort. Yes, we rank all our employees here. From worst performing all the way up to best performing. What? Where do you rank? Let's give it some thought while we complete this assignment. For each 3 things in the inbox, send them to the outbox in order from smallest to largest. Okay, that's a lot of subtractions and lots of branches. Smallest to largest, okay. Inbox, yes, we're gonna have to shuffle 3 numbers. So let's get to it. Right now we have input 2, so I will subtract, let's say input 1. Let's branch if negative. Let's jump over here. Let me actually add comments this time. I made a joke about not doing that before, but this time we really need to keep track of stuff. So we are doing 2 subtract 1. If the answer is negative, then that means 2 is less than 1, right? Because 2 subtract 1, 1 is bigger, yeah. And this is 1 is less than 2, or I guess there's the equal case, but it doesn't really matter because in that case, either branch is fine. If in that case, 1 is less than 2, so let's do get from. Let's get from 1 and subtract 0. Now we have another jump if negative. This case, if 1 minus 0 is negative, it means 1 is less than 0, because 0 is the bigger one. And if it's not negative, it means 0 is less than 1. Alright, so in this case, we know 1 is less than 2 and 0 is less than 1, so now we have everything ordered from smallest to largest. So we have 0 is smallest, then 1, then 2. So copy from 0, send it to the outbox, copy from, no. Copy from 0, send it to the outbox, copy from 1, send to the outbox, get 2 out, and jump back to the beginning. That's our first case. We're gonna have 6 cases total, so wish me good luck. Okay, now this case, 1 is less than 0. We know 1 is less than 2 and 1 is also less than 0, so 1 is going to be the smallest. But we don't know if 0 or 2 is between 0 and 2, which one is the smallest. So we're going to need to go, let me update this. So is 1 is less than 0 and 2. Yeah. And also this one, 0 is less than 1 is less than 2. Just so that I know it's testing both conditions. Otherwise I'm going to forget which branches we've been through. Okay, 0 and 2 we need to compare, so copy from 0, subtract 2, and then jump if negative. In this case, if it's negative, it means 0 is less than 2. So we have 1, 0, 2. So let's do our copy from 1 out, copy from 0 out, copy from 2 out, and jump back to the beginning. Great. Now if it's not negative, it means 2 is smaller than 0. So we have 1, and then 2, and then 0. Copy from 1 out. Copy from 2 out. Copy from 0 out. Jump. And by the way, I know this is super inefficient in terms of size of the program, but I'm hoping I would get the speed challenge with this. Okay, that's the first three cases. Let's just repeat that for the case where 2 is less than 1. So we're gonna have to do the same thing. Let's compare 1 and 0 this time. Be from 1 subtract 0. If that is negative, that means 0 is bigger than 1 or 1 is smaller than 0. So 2 is smaller than 1. No, geez. That means 0 is bigger than 1. Yeah, 1 less than 0. Okay, so let's outbox our stuff. Copy from 2. Copy from 1. Copy from 0. And jump back to the beginning. By the way, this also has a lot of repetition, so I fully expect me to mess up something in the middle. Not the entire logic, but like maybe one of these numbers, or maybe I forget to jump or something like that, but we'll debug that when we get there. Jump if negative. If it's not negative, it means 1 is greater than 0. 1 is greater than 2, and 1 is also greater than 0, so that means we have either 0 or 2, and they're both less than 1. So let's do our next comparison. Copy from 0. Let me do it the other way. Copy from 2 and subtract 0. So now if that's negative, that means 0 is bigger than 2. So we have 2 is the smallest, then 0, then I'm using the wrong notation. 2 is the smallest, then 0, then 1. So copy from 2, box, copy. After that we have 0, out, from 1, out. Should be right. And if this is not, then 0 will be smaller than 2. Right, 0, yeah. So again, we do that. Okay, let's check everything. We got all the inputs. Compare. We got 0, 1, 2, jump. Okay. Compare 1, 2, 0, 1, 2, 0, jump. Good. 1, 0, 2, 1, 0, 2, jump. Yep. 0, 2, 1, 0, 2, 1, jump. 2, 0, 1. Forgot to jump here. See, I told you I'm going to forget something. 2, 0, 1 did the jump. 2, 1, 0, jump. Okay, that's as good as I can make it. Great, yeah, we did get the speed challenge. That's what I'm hoping for. Now let's work on the size. So for that, I will start a completely new program because I don't think we want to optimize this. This is way too much stuff. Alright, so let's get our inbox. Set up our initial stuff. Okay, we got our 3 numbers. Let's subtract. Use 2 and subtract 1. This way we compare 2 with 1. And let's say I want the smallest, medium, big. So if 2 compared to 1 is negative, that means 1 is bigger than 2, and we want the bigger one on this side, which means we want to swap 1 and 2. So copy from 1, put that into a temporary slot, get 2, swap that into 1, and then get our temporary slot, copy it over to 2. Okay, this way we've swapped 2 and 1. So if 1 was bigger than 2 over here, then we just swap them. Actually, if we're jumping if negative, then I actually prefer to do it this way. In that case, we're actually making sure 1 is bigger than 2. And so maybe I'll put the greatest one in front. Once we've compared 1 and 2, we know 2 is the smaller one out of those. So let's compare 1 with 0. Maybe we can optimize this some more, because right now we have the value of 2 in our hands. If we want to compare 1 with 0, then actually we would want to do this in a slightly different order. So copy from 2, put that in. Yeah, let's swap the order here. So at the end we have a copy of value 1 here. Now we can do the comparison against 0. If that's negative, if it's not negative, in other words, 1 is bigger than 0, then we want to swap these two so that 1 becomes the biggest. So let's copy 1, put that in a temporary slot. Maybe, yeah. Copy from 1. Dump that into 0. Copy from our temporary slot. And put that back into 1. Okay. So at this time we know for a fact that 0 contains the largest number, because over here we compared 1 and 2 and made sure 1, the biggest number, goes into slot number 1, and then we compared 1 with 0 and made sure the biggest among those gets into slot 0. So we know slot 0 is the biggest, while 1 and 2 have 2 smaller numbers, and we don't know which one of those is yet. So this is why I did it in this order, because right now we have a copy of the value 1 in our hands, and now we can subtract it against 2 to test which one is bigger. So if this is not negative, that means 1 is bigger than 2, and so we have the correct ordering. But if this is negative, then we will need to swap the two. Actually, it might be more efficient if we just start outputting things, because swapping is going to take 6 instructions anyway, and I don't think we save 6 instructions by merging the outputs. So if this is not negative, again, it means 1 is bigger than 2, so we have everything in the correct order. We just need to copy from 2, send that to the outbox, copy from 1, send that to the outbox, and then 0 have to come after. it is negative. We'll have to do these things in the other order. Make sure we got the correct here, right? Jump if negative, yeah. Jump if negative, that means 2 is actually bigger than 1, which means 1 is the smallest. Get 2, outbox, and then finally we have 0. And I think that's it. Try it. Uh-oh. Expected 1, but I outboxed 5. Something went wrong here. I think it was sorted in the right order, so maybe it's just this last comparison. So I have 1, I compared it with 2, or maybe I should have debugged stuff. Anyway, if it's negative, it means 2 is bigger than 1. So I get 1, I get 2. I'm not sure what's wrong, so let's run it through and debug. Okay. Minus 13. How did I get minus 13 in our hands? Minus 10. Oh. This is definitely something wrong. Ah. I see. Because over here I've subtracted 0, and then if it's negative, I do another subtraction without resetting the value in my hand. That's definitely not good, and this subtraction also needs something. So I guess the order doesn't matter. Let's copy from 1 here, because I'm trying to compare 1 with 0, and copy from 1 here as well, because I'm trying to compare 1 and 2. Not enough stuff. Oh, okay, that's the other thing. I need to make a loop. Go all the way back to the beginning. Oh, we still need to optimize a little bit more. Our size is almost there. When we swap these numbers, these take up a lot of instructions, and I want to see if I can optimize these. So the reason they have to take up so many instructions is because we need to move the original value of 2 to a temporary location, so that when we copy from 1 to 2, we don't lose the original value. So I'm wondering if we can make that a little bit more efficient. Let's say here, instead of just copying to 1, let's make another copy, another backup copy over to 6, so that when we're swapping 2 and 1, we don't have to make a temporary copy. We can just copy from 2, send that to 1, and now luckily we have a backup copy of 1 now. We can copy that into 2, so that saves 1 instruction. And same thing here, when we're swapping between 0 and 1, we could make a temporary copy of 0 up here, so that when we get down here, we don't need to do that. We can copy from 1 to 0, this is correct, and copy from 5, which already has our temporary copy of 0, and copy that into 1. That should be a couple instructions down. Let's look at everything else. When we do the inbox and copy 2, I think this is essential because we need to keep the values later. We need to be able to access all of these. Subtraction and jump is essential because we need to... Oops, this one is wrong. Copy 2, 2. These are essential because we need to be able to tell which one is smaller, and we need to swap this And this is already optimized. This again is essential. And then the last thing is we compare that. If both of these have outbox at the end, we can remove one copy of that and just have the common path do outbox. Other than that, I don't think we can collapse this anymore. Doing a swap here wouldn't help because doing a swap already takes like 4 instructions and we have less than that. So I don't think swapping those will help. So we're going to have to live with a little bit of duplication here. Yeah, I don't think that's going to be enough, but this is the best I can do for now. We're off by 1. Yeah, if I don't find any more ways to optimize this, I might just have to try a completely different approach. I think I found something. Initially, our plan has always been to read everything from inbox, copy them to memory, and then eventually when we want to use them, we have to copy it back from memory and start doing our comparisons. So every time before a comparison, we need to copy something from memory, except this time, except in the beginning where we get our number from the inbox and then we can directly do the subtraction. So what if one of our inbox instructions was down here so that we can skip this copy from instruction? Let's say we were doing something like this, so that we can still write it to memory, but we can immediately do comparison without having to copy it out of memory again. That will save us 1 instruction, which is exactly what we need to complete the challenge. So I think the basic form of the program is like this, but we're going to have to reshuffle the number a little bit. So let's try that. Here we're comparing 2 with 1, so let's copy that into slot 1 first. And our backup copy will be in 6. So we have our number 1, we have our number 2, we're comparing 1 and 2 immediately. So this should still be good. It swaps 1 and 2 using 6 as the temporary number. So after this, we know that 1 is definitely going to be bigger than 2. Right, because we have 2 and 1. If it's not negative, it means 2 is bigger than 1 and we swap it. So now we have 1 is bigger than 2 at this point. Let me make a comment to note that. Okay, and next, this is where we get our new number from the inbox. That's going to be in slot 0. And make a backup copy at 5. We want to subtract 1. This way, we're comparing 0 with 1. And if that's not negative, it means 0 is bigger than 1. And yeah, I'm afraid we're going to have to swap this. Copy from 1 to 0, from 5 to 1. This is the correct swapping. At this point, 1 is still going to have the bigger number. So what we have is 1 is going to be bigger than both 0 and 2. So yeah, we shuffle the order a little bit. Now 1 is going to be the biggest, and 0 and 2 are going to be the smaller ones. So now we're going to have to compare 0 and 2. If it's negative, it means 2 is bigger than 0. So we get 0. This will be a 0 as well. And finally, 1 is our biggest number. And so essentially we shuffle the order of the numbers a little bit, and the instruction that we saved came from here where we had a copy from memory here. But because we got our number from the inbox later than we used to, we no longer need to copy from. Hopefully that'll do it. Yeah! Nice. Alright, let's take our coffee break. Midnight Petroleum. Okay, that looks ominous. It's like machines are taking over the city. Alright, it looks like we're getting into a different section next time, so let's leave it here for today, and we'll get to next time. It looks like something to do with storage. So, that's it for today. Thanks for watching. See you next time.